Here is something that should genuinely disturb you. Every moment of your life appears to flow smoothly into the next. 1 second becomes another. One thought becomes another. One heartbeat becomes another. But physics cannot explain what happens in between. Not before a moment, not after it, between them. What carries reality from one instant into the next? What allows time to continue moving forward? And what if the answer is stranger than anything we have imagined? Tonight we follow one of the deepest mysteries in physics. What exists between moments of time? Time feels smooth. It feels uninterrupted. As you listen to these words, you have the unmistakable sensation that one moment is flowing naturally into the next. The room around you seems stable. Your thoughts appear connected. The sound of a voice, the movement of your eyes, the rhythm of your breathing, all seem to unfold in a seamless stream. But this feeling may be deceiving you. Consider a movie playing on a screen. When you watch a film, you see people walking, cars moving, oceans crashing against the shore. Everything appears fluid and continuous, yet the motion is not actually there. A movie is nothing more than a rapid sequence of still images. Each frame is frozen. The movement exists only because your brain connects those separate images into a single experience. The smooth motion is created inside your mind. Now imagine something even stranger. What if time itself works in a similar way? What if reality only appears continuous because of the way consciousness experiences it? This possibility has fascinated philosophers and scientists for centuries. Our everyday experience encourages us to believe that time flows like a river. We speak of time passing. We say moments move from the future into the present and then disappear into the past. The language feels natural because it matches our experience. Yet when physicists attempt to rise time mathematically, they encounter something unexpected. The equations do not contain a flowing river. They do not contain a moving present. They do not contain a cosmic clock carrying reality forward. Instead, many of the most successful theories in physics simply describe different states of the universe and the relationships between them. The sensation of flow is something we experience, but where that flow actually exists remains uncertain. Think carefully about what you can directly observe. Can you see time itself? Can you touch it? Can you isolate a single piece of it? You can observe clocks. You can observe change. You can watch shadows move across a wall or planets move across the sky. But these are changes occurring within reality. They are not time itself. This distinction may seem small, but it is profound. For thousands of years, human beings assumed that time was a fundamental feature of existence. It appeared so obvious that few questioned it. Days became nights, seasons changed, people grew older. Everything seemed to confirm the existence of an invisible current carrying the universe forward. Yet appearances can be misleading. The Earth feels motionless beneath your feet, even though it is rotating at enormous speed. The sun appears to travel across the sky, even though the motion comes primarily from Earth's rotation. What feels obvious is not always true. Time may belong to the same category of illusions. Some researchers have proposed that continuity itself may emerge from deeper processes hidden beneath reality. Just as a digital image appears smooth, despite being composed of individual pixels, the universe may appear continuous while being built from smaller units that we cannot directly perceive. If this is true, then the flowing's experience of time could be similar to the smooth image on a screen. Real at one level, constructed at another, the idea becomes even more unsettling when we consider human perception. Your brain does not experience reality instantly. Information from your eyes, ears, and nervous system requires time to be processed. By the time you become aware of an event, fractions of a second have already passed. What you experience as the present is actually a carefully assembled reconstruction created by the brain. In other words, your experience of now may already be slightly behind reality. The present moment feels immediate. Yet neuroscience suggests that the mind is constantly integrating information from multiple sources and stitching it together into a coherent experience. The smooth stream of awareness may be less like a live broadcast and more like a continuously updated reconstruction. If consciousness is already assembling reality in this way, then our confidence that time flows smoothly becomes less certain. Perhaps continuity is not a property of time itself. Perhaps continuity is a property of perception. This possibility leads to a remarkable question. When you remember yesterday and anticipate tomorrow, are you observing a genuine flow through time? Or are you experiencing a sequence of states that your mind connects into a story? No one knows for certain. Modern physics has achieved extraordinary success in explaining matter, energy, gravity, and the behavior of particles. Yet the simple feeling that moments flow continuously remains surprisingly difficult to explain. The deeper scientists investigate the foundations of reality, the less obvious continuous time appears, and once that certainty begins to crack, an unsettling possibility emerges. Maybe the smooth passage of time is not a fundamental feature of the universe. Maybe it is only the way the universe appears from within. And if time is not truly continuous, then a far more mysterious question awaits us. What is the smallest possible piece of time? Long before telescopes, particle accelerators, or modern physics, some of the greatest thinkers in history were already wrestling with a question that still troubles science today. Is time actually real? At first, the question sounds absurd. Of course, time is real. You grow older, the seasons change, the sun rises and sets. Every experience of your life seems to confirm that time is constantly moving forward. Yet, several ancient philosophers looked at reality and arrived at a very different conclusion. They believed that the flow of time might be one of the greatest illusions ever experienced by the human mind. One of the earliest and most fascinating examples comes from a Greek philosopher named Parmenides. Living more than 2,000 years ago, Parmenides made a shocking claim. He argued that change itself is impossible. To understand why, imagine a simple question. How does something become different from what it is? If a tree grows taller, there must be a transition between the shorter tree and the taller tree. If a child becomes an adult, there must be a transition between childhood and adulthood. But Parmenides argued that these transitions create logical problems. Something cannot simultaneously be what it was and what it will become. For him, reality had to be complete, whole, and unchanging. If reality is truly real, he reasoned, then it cannot be constantly transforming into something else. Change would be an illusion created by perception. And if change is an illusion, then time, the thing that appears to carry change forward, may also be an illusion. This idea sounds strange even today. Yet Parmenides believed that beneath the shifting appearances of everyday life exists a timeless reality that never moves, never changes, and never becomes anything other than what it already is. The world we experience, according to his view, is not reality itself. It is merely how reality appears to human senses. Another philosopher pushed this mystery even further. His name was Zeno. Zeno became famous for a series of thought experiments that continued to puzzle people centuries later. One of the most famous involves an arrow flying through the air. At first glance, the arrow is obviously moving. You can see it traveling from one location to another, but Zeno asked people to examine the motion more carefully. At any single instant, where is the arrow? It occupies one specific position. At that exact instant, it is simply there. Now examine the next instant. Again, the arrow occupies a specific position, and then another, and another. According to Zeno, If every moment consists of the arrow being fixed in a particular location, where does motion actually occur? If time is made of individual moments, and during each moment the arrow is motionless, then how can motion ever emerge? The paradox appears simple, yet it strikes directly at one of the deepest assumptions we make about reality. We assume movement naturally exists, but Zeno forced people to explain how movement is possible at all. Thousands of years later, mathematicians developed tools that helped address parts of his paradox. Yet the deeper philosophical question remains remarkably powerful. How does a collection of frozen moments create continuous motion? Where exactly does the movement happen? Ancient thinkers in other parts of the world arrived at similar conclusions through very different paths. In India, certain philosophical traditions taught that reality is not a fixed sequence moving through time, but a constantly changing appearance produced by deeper underlying principles. Some schools argued that what we call the present vanishes so quickly that it cannot truly possess a stable existence. Others suggested that the distinction between past, present, and future exists primarily within human consciousness. Meanwhile, certain Buddhist philosophers investigated time by studying direct experience itself. When they searched for the present moment, they encountered a strange problem. The past had already disappeared, the future had not yet arrived, and the present seemed impossible to capture. The instant you attempt to identify the present, it has already slipped into the past. The now appears real, yet it cannot be held, isolated, or examined. It vanishes the moment attention reaches it. This led some thinkers to wonder whether the present is not a thing at all, but a boundary that constantly escapes observation, a dividing line that exists only in experience. Across different cultures and centuries, a common realization kept appearing: human beings experience time. But understanding what time actually is proves extraordinarily difficult. The more closely these philosophers examined it, the less solid it appeared. Time seemed obvious from a distance. Yet, under careful scrutiny, it became strangely elusive, like a mirage that looks substantial until you walk toward it. What makes these ancient ideas remarkable is that they emerged without modern science. These thinkers had no knowledge of relativity, no quantum mechanics, no theories about space-time. Yet many of their questions continue to challenge physicists today. Is change fundamental, or does it emerge from something deeper? Does the present truly exist? Can reality be timeless, beneath its appearance of motion? And is the flow of time something occurring in the universe itself, or something created by the way conscious minds experience reality? The ancient philosophers could not answer these questions. Neither can modern science. But they uncovered a mystery that remains alive after thousands of years. The closer we look at time, the harder it becomes to determine whether it is a feature of reality or a feature of perception. And that mystery becomes even more unsettling when physics introduces a possibility the ancients never imagined. What if time itself has the smallest possible size? For most of human history, people assumed that time could be divided forever. No matter how small a duration became, it seemed reasonable to imagine cutting it into even smaller pieces. A second could be divided into milliseconds. A millisecond could be divided into microseconds. Microseconds could be divided into nanoseconds. The process appeared endless. Time seemed like a perfectly smooth line, stretching infinitely in both directions, with no smallest unit hiding at the bottom. But modern physics introduced a possibility that would have sounded astonishing to ancient philosophers. What if time cannot be divided forever? What if there is a limit? What if reality contains the smallest possible interval, beyond which the concept of time simply loses meaning? To understand why this idea emerged, imagine zooming into reality. Suppose you could shrink yourself smaller and smaller. You pass below the size of cells, then molecules, then atoms, then subatomic particles. Every time you believe you have reached the deepest level, you discover something even smaller. Physics has repeatedly revealed hidden layers beneath what once appeared fundamental. This naturally raises a question. If matter has smaller and smaller structures, what about space and time? Are they also infinitely divisible? Or do they eventually reach a boundary? At first glance, the answer seems obvious. Why would time have a smallest unit? A second already feels arbitrary. Humans invented seconds, nature did not. But physicists are not interested in human measurements. They are interested in the structure of reality itself. And when they combined some of the most important constants in nature, something remarkable appeared. The equations suggested the existence of an incredibly tiny scale where our current understanding of physics begins to break down. A scale so small that space and time themselves may behave very differently from anything we experience. To appreciate how strange this is, think about distance. Imagine walking across a room. The movement feels continuous. You can always move halfway to the wall, then halfway again, then halfway again. Mathematically, there seems to be no end to the process. Now apply the same logic to time. Between any two moments, there appears to be another moment, and between those moments, another. The divisions seem infinite, yet some physicists suspect that nature may not actually work this way. The smoothness we observe could be an illusion created by scales much larger than the fundamental structure underneath. A useful comparison comes from digital images. Look at a photograph on your phone. The picture appears smooth and continuous. Curves look curved, edges look clean, colours blend naturally. But zoom in far enough and the image changes completely. The smooth picture dissolves into individual pixels. What seemed continuous reveals itself to be made from discrete units. The continuity was real at one level of observation, yet beneath it existed a hidden structure. Some researchers wonder whether time might operate in a similar way. Perhaps the flow of moments only appears continuous because we are observing reality from far away. At deeper levels, there may be fundamental intervals that cannot be divided further. This possibility creates a profound shift in perspective. If time has a smallest unit, then the universe may not evolve through an infinitely smooth process. Instead, reality could advance through tiny steps, not unlike frames in a film, not unlike updates in a computer simulation, not unlike a sequence of individual events occurring so rapidly that they merge into apparent continuity. The implications become even stranger when we ask what lies below such a limit. Normally, when we discuss size, we assume smaller levels always exist. But a true fundamental unit changes the question entirely. There would be no below, no hidden layer, no smaller interval waiting to be discovered. The concept itself would stop making sense. Imagine asking what lies north of the North Pole. The question sounds meaningful at first. Yet once you reach the pole, north no longer exists as a direction. The question collapses. Similarly, if time possesses a smallest meaningful interval, asking what happens within a smaller duration may be impossible. Not difficult, not unknown, impossible. The universe may simply refuse to define events on scales beneath that boundary. This idea challenges some of our deepest intuitions. Human beings naturally imagine reality as infinitely divisible. We expect every distance to contain smaller distances. Every duration contains shorter durations. Every process contains finer details. Yet physics repeatedly reveals limits where common intuition fails. There is a speed limit in the universe. Nothing can travel faster than light. There are quantum limits that restrict what can be known simultaneously. And there may also be limits to the divisibility of time itself. What makes this mystery so fascinating is that science has not yet reached a final answer. Experiments have not directly observed a smallest unit of time. No instrument has measured one. No telescope has seen it. No particle accelerator has confirmed it. The idea emerges because our best theories begin to struggle when pushed toward extreme scales. The equations stop agreeing. The known laws of nature stop fitting together. And beyond that boundary lies a region where physicists are still searching for understanding. It is as though reality contains a signpost warning us that we have reached the edge of current knowledge, a place where familiar concepts may no longer apply, a place where space, time, matter, and energy may become parts of something deeper. This brings us to one of the most important numbers ever discovered, a number so small that it represents the frontier between known physics and the unknown, a number called Planck time, and it may be the closest thing science has to the smallest possible unit of time. 4. What is Planck time and why? It changes everything. Lesson 4. What is Planck time and why it changes everything? If there is a place where modern physics meets mystery, it is here. The idea of Planck time sounds technical at first. It sounds like one of those scientific numbers that exists only in textbooks. But hidden inside this tiny unit of time is a possibility that could completely change how we understand reality itself. Because Planck time is not merely a measurement. It may represent a fundamental boundary of existence, a boundary beyond which the universe refuses to reveal what happens. To understand why physicists take this idea seriously, we need to travel back to the beginning of a problem. Modern physics is built upon two extraordinarily successful theories. One is Einstein's theory of relativity. The other is quantum mechanics. Relativity describes gravity, space, time, planets, stars, galaxies, and the large-scale structure of the universe. Quantum mechanics describes atoms, particles, energy, and the microscopic world. Both theories have survived countless experimental tests. Both predict reality with astonishing accuracy. Yet there is one problem. They do not fully agree with each other. When physicists try to apply both theories simultaneously at extremely tiny scales, the mathematics begins to collapse. The equations stop making sense. Predictions become impossible. The universe seems to enter a region where our current understanding breaks apart. And this breakdown occurs near a specific scale, a scale associated with Planck time. Planck time is approximately 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 meaningless. Light, which travels faster than anything else in the universe, would move only 1 Planck length during this interval. That distance is unimaginably tiny. If an atom were expanded to the size of a galaxy, a Planck length would still appear incredibly small by comparison. Human intuition completely fails at these scales. There is nothing in ordinary experience that prepares us to imagine something so small. Yet physicists believe this number may reveal something profound. Planck time is often described as the smallest meaningful interval of time, according to our current theories. Not because science has proven that time comes in pieces, not because anyone has measured individual units of time, but because below this scale, our equations lose their ability to describe reality. Imagine standing on the edge of a map. Everything behind you is familiar territory: mountains, rivers, cities, roads. But beyond the edge, the map becomes blank, not because nothing exists there, but because the map no longer works. That is essentially what Planck time represents. The edge of the map, the place where known physics reaches its limit. Beyond it, nobody knows what reality looks like. This creates a fascinating possibility. Suppose someone asked what happens during half of a Planck time. The question sounds reasonable. After all, we are accustomed to dividing everything into smaller parts, half a second, half a centimetre, half a day. Why not half a Planck time? The strange answer is that physics may not even be able to define such a thing. If Planck time truly represents a fundamental limit, then asking about smaller intervals may be like asking what is north of the North Pole. The question appears meaningful, yet the concept itself may no longer apply. Time, as we understand it, may simply cease to exist below that scale. This is where the mystery becomes truly unsettling. Everything in your life depends on time. Every memory, every thought, every heartbeat, every movement of every particle in your body. Yet when we push our understanding deep enough, time itself begins to dissolve. The very framework through which we experience existence starts losing definition. Imagine zooming into reality with an impossibly powerful microscope. At first you observe people, then cells, then molecules, then atoms, then particles. Everything seems structured, everything seems understandable. But eventually you reach a level where space and time themselves stop behaving like smooth backgrounds. Instead, they become unstable, chaotic, uncertain. The familiar stage upon which reality unfolds begins to disappear. Some physicists describe this region as quantum foam, a realm where space-time may fluctuate violently. At these scales, the distinction between space and time becomes blurred. Distances may lose their meaning. Durations may lose their meaning. The concepts that organize our experience could emerge only at larger scales. In other words, time may not be fundamental at all. It may be something that emerges from deeper processes occurring beneath the Planck scale. Think about a wave moving across the ocean. From far away, the wave appears smooth and continuous. But up close, the wave is not a separate object. It emerges from countless interactions between individual water molecules. The wave is real, yet it is not fundamental. It is a large-scale pattern arising from something deeper. Many researchers wonder whether time could be similar. The flowing passage of moments may be a large-scale phenomenon, an emergent feature of reality, something that appears when viewed from our level of existence, but disappears when examined at the deepest levels. If this idea is correct, then one of the oldest assumptions in human history may be wrong. Time may not be the foundation of reality. Reality may exist beneath time, and time may emerge from it. This possibility completely transforms the question we began with. We originally asked what exists between moments of time, but Planck time suggests an even stranger possibility. What if moments themselves are not fundamental? What if they emerge from something deeper that does not resemble time at all? At that point, the mystery is no longer about measuring smaller intervals. It becomes a question about the very architecture of existence. And once that possibility is considered, another extraordinary idea begins to emerge. What if the universe does not flow continuously at all? What if reality advances through discrete steps like frames in a cosmic film? Imagine pausing reality, not slowing it down, not freezing a photograph, actually stopping the universe at a single instant. Every star hangs motionless in space. Every atom stops vibrating. Every particle becomes fixed exactly where it is. Every thought inside every mind is suspended. Nothing moves, nothing changes. The entire universe exists as a single frozen moment. Now imagine the universe suddenly advances to the next instant. A tiny change occurs. Particles occupy slightly different positions. Light moves slightly farther through space. Hearts beat once more. Thoughts continue. Reality progresses by one step, then another, then another. What if this is how the universe truly operates? What if time does not flow continuously at all? What if reality advances through a sequence of individual frames, similar to a film projected onto a screen? At first, this idea sounds impossible. Everything around us appears smooth. A bird flies across the sky without interruption. Ocean waves roll continuously toward the shore. Voices flow naturally from one word to the next. Nothing about ordinary experience suggests that reality is composed of separate moments. Yet appearances can be deceptive. A movie also appears smooth. When you watch a film, you see continuous movement. People walk. Cars race down roads. Entire stories unfold naturally before your eyes. But the motion is not actually there. The film consists of individual still images shown rapidly one after another. Your brain creates the illusion of continuity. The movement exists in perception, not in any single frame. A modern digital screen works in a similar way. The image appears stable, yet the display constantly updates. Thousands of changes occur every second. The updates happen so quickly that the eye experiences them as a single continuous scene. Reality itself may operate according to a similar principle. Some physicists and philosophers have explored the possibility that time could be fundamentally discrete. In this view, the universe would not evolve through an infinitely smooth flow. Instead, existence would advance through tiny increments. Reality would update from one state to another. The intervals would be so unimaginably small that continuous motion would emerge as an illusion at larger scales. This possibility becomes especially interesting when combined with the concept of Planck time. If there truly exists a smallest meaningful interval of time, then perhaps reality cannot change continuously below that scale. Instead, every event in the universe may occur through individual steps, separated by tiny intervals that cannot be divided further. Think about a staircase. From a distance, a staircase can sometimes appear like a smooth slope. But as you approach, the structure becomes visible. You see distinct steps. The apparent smoothness was created by perspective. Some researchers wonder whether time itself might resemble such a staircase. At humans' scales, everything appears continuous. At deeper levels, reality may consist of discrete transitions. This raises a remarkable question. If the universe advances frame by frame, what happens between the frames? The answers may be even stranger than the question. There may be no between. Our minds naturally assume that every interval contains smaller intervals. We imagine a gap between one moment and the next. But if time is truly discrete, then no intermediate duration exists. There would be one moment, then another, nothing in between. Just as there is no halfway point between two adjacent pixels on a screen, there may be no smaller temporal regions separating fundamental moments. This challenges one of the deepest assumptions built into human intuition. We instinctively imagine continuity. We imagine reality unfolding through an endless chain of connected durations. But discrete time suggests that continuity may emerge from sequences rather than existing fundamentally. The consequences become increasingly difficult to visualize. Consider motion. When you watch a ball roll across a floor, you assume it occupies every point along its path. But in a frame-based universe, the ball might occupy one position during one fundamental instant and a slightly different position during the next. The smooth path would emerge only when countless frames are viewed together now. Consider thought itself. Every memory, every decision, every emotion, every moment of awareness. Could consciousness also unfold frame by frame? Could the stream of experience be composed of individual states linked together so seamlessly that the mind never notices the transitions? Some philosophers have seriously explored this possibility. The question becomes especially fascinating because human awareness already seems to process reality in chunks. Neuroscience suggests that the brain gathers information over brief intervals before constructing a unified experience. Your perception of the present may already be assembled from tiny windows of information rather than existing as a perfectly continuous stream. The world feels uninterrupted. but the mechanisms creating that experience may operate through discrete stages. This does not prove that time itself is discrete, yet it reveals that continuity can emerge from systems built upon individual units. Language provides another example. A sentence feels like a continuous flow of meaning, yet it is constructed from separate words. Words are built from individual letters. Letters are composed of distinct symbols. The larger pattern appears seamless despite being assembled from discrete parts. Reality may possess a similar architecture, a continuous universe emerging from discrete foundations. But there is a major challenge. No experiment has yet demonstrated that time is made of frames. Physicists have searched for evidence that space-time possesses a granular structure. Some theories predict subtle effects that might eventually reveal such a structure. Others suggest that the universe is fundamentally continuous after all. At present, science does not have a definitive answer. This uncertainty is important. The frame-based universe remains a possibility, not a proven fact. Yet it remains one of the most intriguing possibilities because it offers a radically different picture of existence. Instead of a river flowing through time, reality becomes a sequence of states. Instead of continuous evolution, the universe becomes a chain of transitions. Instead of asking what carries reality smoothly from one moment to the next, we begin asking how one frame becomes another. And that question leads directly into an even deeper mystery. Because when physicists examined the microscopic world where these transitions occur, they discover something profoundly unsettling. At the quantum level, reality itself seems to resist the very idea of continuous existence. And the strange events unfolding there may hold clues about what truly exists between moments. If the idea of time being made of individual frames sounds strange, the quantum world is stranger, much stranger. Because when physicists began investigating reality at its deepest levels, they did not find a miniature version of the world we experience every day. They did not find tiny planets orbiting tiny suns. They did not find a clockwork universe operating according to simple mechanical rules. Instead, they discovered a realm so unfamiliar that even the scientists who uncovered it struggled to understand what they were seeing. A realm where certainty disappears. A realm where possibilities seem as important as actual events. A realm where reality itself appears incomplete until something happens. And hidden within this strange world may be clues about what exists between moments of time. To appreciate how unusual the quantum world is, imagine watching a ball roll across a floor. You can see where it is. You can measure its speed. You can predict where it will be a few seconds later. Everything feels straightforward. The ball follows a path. It occupies specific locations. It moves continuously from one position to another. Now imagine shrinking yourself smaller than an atom. Suddenly the rules begin to change. An electron does not behave like a tiny ball. A photon does not behave like a tiny object. The particles that form reality refuse to fit comfortably into ordinary categories. Sometimes they behave like particles. Sometimes they behave like waves. Sometimes they behave like neither. And this is where one of the deepest mysteries emerges. According to quantum mechanics, particles often do not possess definite properties in the way we expect. Instead, they exist in what physicists call a superposition, a state containing multiple possibilities simultaneously. This idea is difficult because human intuition was never designed to understand it. Imagine a coin spinning rapidly in the air. Before it lands, you know it could become heads or tails, but the coin itself remains a definite object throughout the process. Quantum particles appear different. The mathematics suggests that before measurement occurs, reality is not merely unknown. It may genuinely exist as a range of possibilities. Only when an interaction takes place does one specific outcome emerge. This leads to an unsettling question. What exactly happens between one defined state and the next? Where does the transition occur? How does possibility become reality? For nearly a century, physicists have debated this question. And despite extraordinary advances in technology and theory, nobody possesses a universally accepted answer. The equations successfully predict outcomes, but the deeper meaning remains controversial. This becomes particularly important when we think about time. In everyday life, we imagine reality evolving continuously. One event causes another. One moment produces the next. But quantum mechanics often describes systems using probabilities rather than definite trajectories. The future exists as a collection of possible outcomes. Only later does a specific outcome appear. It is as though reality explores multiple possibilities before settling on a particular result. The process is difficult to visualize because it does not resemble anything in ordinary experience. Yet experiments repeatedly confirm that quantum systems behave in ways that challenge classical assumptions. One of the most famous examples is the double-slit experiment. At first glance, the setup seems simple. Particles are directed toward a barrier containing two openings. A detector behind the barrier records where the particles arrive. If particles behaved like tiny bullets, they would pass through one slit or the other. The resulting pattern would be predictable. But that is not what happens. Instead, the particles produce an interference pattern associated with waves. Even more astonishing, this pattern emerges when particles are sent one at a time. The results suggest that each particle somehow behaves as though it explores multiple possibilities before arriving at a final outcome. The experiment has inspired endless debate because it appears to challenge our understanding of how reality unfolds. The deeper physicists investigate, the more difficult it becomes to describe what occurs between preparation and observation. The question is no longer simply where a particle is. The question becomes what reality itself is doing between events. This uncertainty creates a fascinating connection to our larger mystery. If reality is not fully determined between observations, then what exactly exists during those intervals? Are we witnessing genuine gaps in physical description? Or are deeper processes operating beyond our current understanding? Some interpretations of quantum mechanics suggest that possibilities remain real until interactions force a specific outcome. Others argue that all possible outcomes continue to exist in parallel branches of reality. Still others propose that hidden variables operate beneath quantum phenomena, preserving determinism in ways not yet understood. The remarkable fact is that different interpretations often produce identical experimental predictions. The mathematics works. The philosophical meaning remains uncertain. This leaves physicists in a peculiar position. They can calculate astonishingly accurate results while still debating what those results actually imply about reality. The mystery deepens when we consider quantum jumps. Certain quantum systems appear to transition between states in ways that seem abrupt rather than continuous. An electron occupying one energy level may later be found occupying another. The transition itself does not resemble a tiny object traveling through intermediate positions. Instead, it appears as though the system mind changes state. For decades, scientists argued about whether these jumps represented genuine features of nature or merely limitations in observation. Modern experiments have revealed that the process is more subtle than originally believed. Yet the underlying mystery remains. How does one quantum state become another? What occurs during the transformation? The closer we examine the transition, the more elusive it becomes. It is almost as though reality resists, being frozen and inspected while it changes. Another astonishing feature of quantum physics is entanglement. Two particles can become connected in ways that defy ordinary intuition. After interacting, their properties remain correlated even when separated by enormous distances. Measure one particle, and information about the other immediately becomes available. Einstein famously disliked this implication. He referred to it as spooky action at a distance. Today, entanglement is among the most thoroughly tested phenomena in physics, yet it continues to raise profound questions. If reality contains deep connections that transcend ordinary spatial separation, what does this imply about time? Could the structure connecting moments also operate in ways we do not yet understand? Could the universe possess hidden relationships extending across temporal boundaries just as entanglement links distant locations? No one knows. But these questions reveal how much remains mysterious beneath familiar appearances. The quantum world repeatedly demonstrates that reality is not obligated to conform to human expectations. Concepts that feel obvious often fail at fundamental scales. Continuity becomes uncertain. Location becomes uncertain. Causality becomes more subtle. Even the distinction between what exists and what might exist begins to blur. Some researchers have proposed that time itself may emerge from quantum processes. Rather than existing as a fundamental background, time could arise from relationships between quantum events. In such theories, the flow of moments would not be a basic ingredient of reality. It would be a consequence, an emergent phenomenon appearing only when countless microscopic interactions combine into larger structures. This possibility carries extraordinary implications. If time emerges from quantum processes, then asking what exists between moments may be similar to asking what exists between individual waves in the ocean. The deeper level may not contain smaller moments at all. It may contain something entirely different, something from which moments themselves emerge, something more fundamental than time. Physicists have not yet discovered whether this picture is correct. Quantum gravity remains unfinished. The deepest structure of space-time remains unknown. The bridge between quantum mechanics and relativity remains incomplete. Yet every attempt to solve these problems leads toward the same unsettling realization. The closer we approach the foundations of reality, the less obvious time becomes. What once appeared to be the most familiar feature of existence begins to dissolve into mystery. And that mystery reaches a new level when we encounter a question so simple that it seems impossible to answer. A question that physics still struggles to define. What exactly is the present moment? Because before we can understand what exists between moments, we must first understand something even more puzzling. What is a moment in the first place? The present moment feels like the most obvious thing in existence. You are experiencing it right now, not yesterday, not tomorrow, now. Every thought you have occurs in the present. Every sound you hear exists in the present. Every decision you make unfolds in the present. The entire structure of human experience seems built around a moving point called now. Yet when physicists attempt to locate this present moment within the laws of nature, something astonishing happens. They cannot find it, not because the present is difficult to measure, not because it is hidden, but because the equations themselves contain no obvious place for it. The present moment, which feels more real than anything else in your life, seems strangely absent from the deepest descriptions of reality. This creates one of the most unsettling mysteries in modern physics. Because if science cannot clearly define the present, then what exactly are we experiencing every second of our lives? To understand the problem, imagine standing beside a river. You watch the water move past you. The current flows continuously. The water that was in front of you a moment ago is already gone. New water arrives. The flow feels undeniable. For centuries, human beings imagined time in a similar way. The future flows into the present. The present flows into the past. reality advances through an ever-moving stream of moments. The image feels natural because it matches experience. But physics tells a different story. When scientists write equations describing motion, gravity, light, energy, or particles, the equations do not include a special moving present. There is no variable labeled now. There is no universal clock carrying the universe forward. The laws simply describe relationships between events. Past, present, and future often appear as coordinates within a mathematical structure. Nothing inside the equations identifies one particular moment as the current moment. This may sound like a technical detail. It is not. It strikes directly at the center of how we experience existence. Imagine reading a novel. As a reader, you experience the story page by page. Events unfold sequentially. The future chapters have not happened yet. The previous chapters are finished. Only the current page feels present. But imagine someone holding the entire book in their hands. From that perspective, every page already exists. The beginning exists. The middle exists. The ending exists. The reader experiences progression. The book itself simply exists as a complete structure. Many physicists argue that reality may resemble the second perspective more than the first. The universe may not contain a moving present. Instead, all events may exist within space-time, as part of a larger structure. The sensation of moving through time could arise from consciousness rather than from the universe itself. This idea feels deeply counterintuitive because the present appears so immediate. Surely there must be a special distinction between what is happening now and what happened millions of years ago. Yet relativity complicates this intuition in remarkable ways. According to Einstein, there is no single universal present shared by the entire cosmos. Different observers moving relative to one another can disagree about whether certain events occur simultaneously. An event that appears to happen now from one perspective may not appear simultaneously from another. This is not an illusion. It is built directly into the structure of space-time. Imagine two observers separated by enormous distances. Because information cannot travel faster than light, there is no absolute cosmic clock synchronizing every event throughout the universe. The concept of a universal present begins to dissolve. The farther we expand our perspective, the harder it becomes to define a single moment that everyone could agree represents now. This creates a startling realization. The present may not be a fundamental feature of reality. It may be a local experience, a perspective-dependent phenomenon emerging from our position within space-time. The implications are difficult to absorb. Every human culture organizes life around the distinction between past, present, and future. Memory points backward. Expectation points forward. Action occurs in the present. The entire architecture of consciousness appears built upon these categories. Yet physics suggests that the universe itself may not divide reality in this way. The divisions may belong to experience rather than existence itself. The mystery deepens when we examine the duration of the present. How long does now actually last? The question seems simple, yet it quickly becomes problematic. Suppose the present lasts 1 second, then the first half of that second belongs to the present, but so does the second half. This means the beginning of the present already differs from its ending. The interval contains change. If change occurs within it, then it cannot be a single instant. Perhaps the present lasts 1 millisecond. The same problem appears, perhaps 1 microsecond. Again, the same issue emerges. No matter how small the duration becomes, it can always be divided into earlier and later portions. The present seems impossible to isolate. It continually slips away. The moment you attempt to identify it, it becomes part of the past. This problem troubled philosophers long before modern physics existed. Yet science has inherited the same puzzle. What exactly is the present? A duration? an instant, a boundary, an illusion, a feature of consciousness. No consensus exists. Neuroscience introduces another layer of complexity. Your brain does not process reality instantaneously. Light reaches your eyes. Signals travel through neurons. Information is integrated and interpreted. The experience you call the present may actually represent information collected over a brief interval and assembled into a coherent perception. In other words, your awareness of now may already be slightly delayed. The present you experience may not correspond to a precise instant in the external world. Instead, it may be a constructed window of experience generated by the brain. This possibility is extraordinary. The most immediate aspect of consciousness may itself be a reconstruction. The feeling of occupying a single present moment could emerge from neurological processes that combine information across time. If this is true, then the present may not exist is exactly where we think it does. It may not be a razor-thin slice separating past and future. It may be a cognitive phenomenon, a useful interpretation generated by biological systems attempting to navigate reality. Yet even this explanation leaves deeper questions unanswered. Why does consciousness experience a present at all? Why does awareness seem attached to a moving point in time? Why do memories point backward, while possibilities point forward? Physics successfully describes countless processes, but the feeling of being located in a present moment remains surprisingly difficult to derive from fundamental laws. Some researchers believe the answer may lie in entropy, the tendency of systems to move from ordered states toward greater disorder. Others suggest that consciousness itself may play a role. Still others argue that the mystery reflects limitations in current theories rather than features of reality. No definitive answer has emerged. The present remains one of the strangest concepts in science. We cannot avoid it. We experience it constantly, yet the more carefully we examine it, the more elusive it becomes. It resembles a shadow that retreats whenever we try to touch it. A boundary that seems obvious from within experience, but difficult to locate within physics. As this leads to a remarkable possibility. Perhaps the reason physics struggles to describe the present is because reality is not fundamentally organized around a moving now at all. Perhaps the universe operates according to principles far stranger than human intuition expects. Perhaps moments do not flow. Perhaps they update. Perhaps reality itself functions more like a vast computational process than a continuously moving stream. And if that possibility sounds impossible, the next mystery will make it even harder to dismiss. Because some physicists and philosophers have begun asking a question that once belonged entirely to science fiction. What if the universe updates itself like a cosmic computer? 8. Does reality update like a cosmic computer? Imagine pausing a video game. The world appears complete. Mountains stand in the distance. Cities remain frozen in place. Characters stop moving. Nothing changes. Then you press a button and the world comes alive again. Objects move. Light shifts. Events continue. To the characters inside that digital world, if they were conscious, everything might appear smooth and continuous. They would experience motion. They would experience cause and effect. They would experience the passage of time. Yet, beneath their experience, something very different would be happening. The computer would not be creating reality continuously. It would be updating information. Frame after frame, calculation after calculation, state after state. The apparent flow would emerge from countless rapid updates occurring beneath awareness. Now consider a startling possibility. What if our universe operates in a somewhat similar way? Not necessarily as a literal computer simulation, not necessarily as a virtual world created by some external intelligence, but as a reality whose deepest structure may be informational rather than continuous. a universe that evolves through updates rather than through an endlessly flowing river of time. This idea sounds like science fiction, yet, surprisingly, it emerges from serious attempts to understand the foundations of physics. Because the deeper scientists investigate reality, the more frequently information appears at the center of the story. Matter can be described through information. Quantum states contain information. Black holes appear connected to information in profound ways. Even the laws of physics themselves resemble rules governing how information changes over time. This has led some researchers to ask a remarkable question. What if information is more fundamental than matter? What if physical reality emerges from informational processes occurring beneath the world we experience? To understand why this possibility attracts attention, consider how a computer simulation operates. A simulated universe does not need to calculate every possible detail continuously. Instead, it updates its state according to rules. One frame contains a specific arrangement. The next frame contains a slightly different arrangement. The sequence creates the appearance of motion. The flow emerges from transitions between states. Some physicists have noticed that certain features of reality resemble this structure. Quantum systems often evolve through discrete interactions. Information appears quantized. Certain physical quantities occur in distinct units rather than continuous values. The universe sometimes behaves less like a smooth analog process and more like a system built from fundamental pieces. This does not prove that reality is computational, but it raises intriguing questions about the nature of change. When one moment becomes another, what is actually changing? What carries information from one state of the universe into the next? What mechanism allows reality to remain coherent across time? Ordinarily, we assume these questions have obvious answers. Time flows, things change, the universe evolves. Yet those words merely describe the mystery. They do not explain it. Saying that time flows does not tell us what flow is. Saying that reality evolves does not explain how one state becomes another. At the deepest level, the process remains surprisingly mysterious. Imagine a book. Every page contains information. The story progresses from beginning to end, but the progression exists primarily for the reader. The pages themselves simply exist. The narrative emerges through sensual experience. Now imagine a computer file. The information exists as patterns stored within a system. The story appears when those patterns are processed. Some researchers wonder whether reality may possess a similar structure. The universe may contain information arranged according to deep mathematical principles. The passage of time could emerge from how that information is organized and experienced. One reason this possibility gained attention comes from the study of black holes. Black holes are among the most extreme objects in existence. Their gravity becomes so intense that not even light can escape. For decades, physicists believed that information falling into a black hole might be destroyed forever, but this created a serious problem. The laws of quantum mechanics strongly suggest that information cannot simply disappear. The contradiction became known as the black hole information paradox. Years of research eventually revealed something extraordinary. Information appears far more fundamental than many scientists previously believed. Some physicists now argue that information may be one of the basic ingredients of reality itself, not merely a description of physical systems, a fundamental aspect of existence. This shift in perspective changes how we think about time. Instead of imagining the universe as a collection of objects moving through an independent temporal background, we begin imagining a network of relationships and information constantly updating according to underlying rules. The focus moves away from things. It moves toward processes, toward patterns, toward transformations. The universe begins to resemble an unfolding computation. Again, this does not mean reality literally runs on a giant computer. That interpretation is often misunderstood. The deeper idea is that information and computation may provide useful ways to understand how reality evolves. The comparison becomes even more interesting when we consider digital images. A photograph appears continuous, yet it consists of pixels. A video appears fluid, yet it consists of frames. Music streaming through headphones sounds seamless, yet it consists of discrete packets of information processed at extraordinary speed. Human perception naturally smooths these structures into continuous experiences. Could something similar happen with time? Could the flow of moments emerge from processes occurring beneath the threshold of perception? If reality updates rapidly enough, the transitions would become invisible. The universe would appear continuous, even if its underlying structure were not. The idea remains speculative. No experiment has proven that the universe updates like a computer. No instrument has detected cosmic frames. No observation has revealed a universal refresh rate. These concepts remain possibilities rather than established facts. Yet they continue to attract attention because they offer potential solutions to difficult problems. They provide new ways of thinking about quantum mechanics, new approaches to space-time, new perspectives on information, new frameworks for understanding emergence. And perhaps most importantly, they force us to reconsider assumptions that usually go unquestioned. For example, why should time flow at all? Why should moments naturally become future moments? Why should reality continuously update itself? These questions often remain hidden because the passage of time feels so familiar. Yet familiarity is not an explanation. The mystery remains. Whether reality flows, updates, emerges, or exists timelessly, something extraordinary is occurring. The universe continually presents new states, new configurations, new experiences. The process is so ordinary that we rarely notice how astonishing it actually is. Every second, reality transforms. Every instant, the entire cosmos becomes different from what it was before. And yet physics still struggles to explain the deepest mechanism behind that transformation. Some researchers believe information holds the key. Others believe space-time itself must be rebuilt from more fundamental ingredients. Still others argue that entirely new theories will be required. No consensus exists, but one thing is clear. The closer we examine reality, the less certain the traditional picture becomes. The universe may not resemble a clock. It may not resemble a flowing river. It may not resemble any object familiar to human experience. The true architecture of existence may be far stranger than intuition allows. And before we can understand whether reality updates like a cosmic computation, we must first confront the scientist who transformed humanity's understanding of time more radically than anyone in history. Because the next step in this mystery begins with a realization that shattered centuries of assumptions. A realization that revealed time is not what it appears to be. A realization discovered by a young physicist named Albert Einstein. For thousands of years, human beings believed they understood time. The sun rose, the sun set, days passed, years passed, people grew older, empires rose and fell. Everything seemed to confirm a simple idea. Time moved forward at the same rate for everyone. A second was a second, an hour was an hour. The universe appeared to operate according to a single cosmic clock, ticking uniformly throughout existence. This assumption felt so obvious that almost nobody questioned it. Even many of the greatest scientists accepted it. Time was treated as a fixed background against which reality unfolded. Events happened within time, but time itself remained untouched, unchanging, universal absolute. Then, at the beginning of the 20th century, one man challenged that entire picture, and in doing so, he transformed humanity's understanding of reality forever. That man was Albert Einstein. The revolution he began did not merely change physics, it changed the meaning of time itself. The story begins with a simple question. Imagine you are sitting on a train moving at extraordinary speed. You throw a ball into the air. To you, the ball travels straight up and straight down. The motion feels perfectly normal. Now imagine someone standing beside the tracks watching the same event. From their perspective, the ball does not move straight up and down. It follows a curved path because the train continues moving while the ball is in the air. Both observers witness the same event, yet they describe it differently. This fact was already understood before Einstein, but light created a deeper problem. Experiments suggested that the speed of light remains constant, regardless of the observer's motion. Whether you move toward light or away from it, the speed remains the same. This result seemed impossible. According to common sense, velocities should combine. If a car drives toward you, its speed relative to you changes. Why should light behave differently? Einstein took this mystery seriously, and the consequences were astonishing. To preserve the constant speed of light, reality itself had to change. Space could no longer remain fixed. Time could no longer remain fixed. Both had to become flexible. Both had to depend upon motion. The implications were extraordinary. Two observers moving differently through space could experience time differently, not metaphorically, not psychologically, physically, objectively. Reality itself would measure time differently for them. This effect became known as time dilation. Imagine two perfectly synchronized clocks. One remains on Earth. The other travels aboard a spacecraft, moving at tremendous speed. When the spacecraft returns, the clocks no longer agree. The moving clock records less time. Its journey through time has been slower. This is not science fiction. It is one of the most thoroughly tested predictions in modern physics. Atomic clocks placed on aircraft experience measurable differences compared to clocks on Earth. Satellites orbiting our planet must account for relativistic time effects. Without these corrections, technologies such as GPS would quickly become inaccurate. The evidence is overwhelming. Time does not pass at the same rate for everyone. The speed at which time flows depends on motion. Pause for a moment and consider how strange this really is. Somewhere in the universe, two observers may experience different amounts of time between the same events. One person may age slightly less than another. One clock may tick slower than another, not because the clocks malfunction, not because perception changes, because reality itself behaves differently. The universe possesses no single universal clock. The idea humanity trusted for centuries was wrong, but Einstein's discoveries became even stranger. Motion is not the only thing that affects time. Gravity affects time as well. The stronger the gravitational field, the slower time passes. This sounds almost impossible to believe, yet experiments repeatedly confirm it. A clock placed near a massive object runs slightly slower than a clock farther away. Time near Earth's surface passes more slowly than time farther from Earth. Near a neutron star, the effect becomes much stronger. Near a black hole, it becomes extraordinary. Imagine standing far away from a black hole while observing someone approaching its edge. From your perspective, their clock slows dramatically. Their movements appear increasingly delayed. Time itself seems to stretch. Near the boundary of the black hole, the flow of time becomes radically different from what you experience. The implications are profound. Time is not an independent river flowing equally everywhere. Time interacts with matter. Time interacts with gravity. Time interacts with motion. It bends. It stretches. It changes. The universe turns out to be far more dynamic than anyone imagined. This realization forced physicists to rethink one of the deepest assumptions about reality. Perhaps time is not separate from space at all. Einstein proposed something revolutionary. Space and time form a unified structure known as space-time. Instead of imagining 3 dimensions of space and 1 separate dimension of time, reality becomes a 4-dimensional fabric. Every event occupies a location in space-time. Every particle follows a path through space-time. Every moment of existence becomes part of this larger structure. This idea sounds abstract until we consider its implications. When you travel through space, you also travel through time. The two are inseparably connected. Motion through one affects motion through the other. The universe no longer resembles a stage where time passes independently. The stage and the passage are woven together. Space-time becomes the arena of existence itself. This framework solved many problems. It explained observations that previous theories could not. It predicted phenomena later confirmed through experiments. Yet it also introduced a new mystery, a mystery directly connected to our search for what exists between moments. Because once space-time enters the picture, the present moment begins to lose its special status. In ordinary experience, the present feels uniquely real. The past has vanished, the future has not arrived, only now exists. But relativity complicates this intuition. Different observers moving relative to one another can disagree about which events occur simultaneously. There is no universal now shared by the entire cosmos. An event you consider present may not be present for someone moving differently through space-time. This is not a flaw in perception. It is a consequence of reality itself. The universe contains no single cosmic present. The deeper physicists explored this implication, the more radical it became. If there is no universal present, perhaps past, present, and future do not possess the distinctions we imagine. Perhaps all events simply exist within space-time. This positivity eventually inspired one of the most astonishing interpretations of Einstein's work, an interpretation known as the block universe. In this view, time does not flow at all. The universe exists as a complete 4-dimensional structure. Past events remain part of reality. Future events remain part of reality. The sensation of moving through time emerges from consciousness rather than from the structure of space-time itself. Whether this interpretation is correct remains debated, yet its roots lie directly within Einstein's revolution. A revolution that transformed time from an absolute background into a dynamic dimension woven into the fabric of existence. The deeper message is difficult to ignore. Before Einstein, time seemed obvious. After Einstein, time became mysterious. The closer we examine reality, the less familiar it appears. The present loses its certainty. The flow of time loses its simplicity. The universe reveals a structure stranger than common sense ever imagined. And this realization prepares us for an even more disturbing possibility. Because if Einstein's space-time already contains all events within a single structure, then perhaps the future is not something that will exist. Perhaps it already exists. Perhaps the past has never disappeared. And perhaps the distinction between yesterday, today, and tomorrow is not fundamental to reality at all. To explore that possibility, we must enter one of the most unsettling ideas ever proposed in physics, the theory known as the block universe, a theory that challenges everything we believe about time, change, and the passage of moments. Imagine holding your entire life in your hands, not as memories, not as photographs, not as a timeline stretching from birth to death. Imagine every moment existing simultaneously, your first breath, your childhood, this very second, your final day, all existing together as parts of a single structure. You are not moving through it, you are simply located within it. At first, this idea feels impossible. Everything in human experience tells us that time flows. Yesterday is gone, tomorrow has not arrived. The present moves steadily forward. Life unfolds moment by moment. the future becomes the present becomes the past. This process feels so obvious that most people never question it. Yet one of the most astonishing implications of modern physics suggests that this picture may be fundamentally wrong. According to an interpretation known as the block universe, the flow of time may not exist at all. The universe may instead be a complete four-dimensional structure in which all events already exist. Past events, present events, future events, all woven together within space-time. Nothing enters existence, nothing leaves existence. Everything simply is. This idea did not emerge from fantasy. It emerged from attempts to understand the implications of Einstein's theory of relativity. As physicists explored the consequences of space-time, they encountered a disturbing realization. The universe contains no universal present, no cosmic now, no moment shared equally by all observers. Different observers moving differently through space-time can disagree about which events are simultaneous. This fact seems technical at first, but its implications are profound. Because if there is no universal present, what exactly separates past from future? What makes one moment special? What grants the present its privileged status? The deeper physicists investigated, the more difficult these questions became. Eventually, some thinkers arrived at a radical conclusion. Perhaps no moment is objectively special. Perhaps the distinction between past, present, and future exists primarily within conscious experience. Reality itself may simply contain all events. The universe becomes something like a completed landscape, not a process unfolding, not a story being written, a structure already existing in its entirety. To understand this concept, imagine a long road stretching across a vast desert. A traveller standing on the road can see only a small portion around them. The section behind appears to belong to the past. The section ahead appears to belong to the future. But from the perspective of someone viewing the entire road from above, all sections exist simultaneously. Nothing needs to be created. Nothing needs to move into existence. The entire road is already there. The traveller's experience creates the impression of progression. The larger structure simply exists. According to the block universe, time may work similarly. Human consciousness occupies a particular location within space-time. From that position, events appear sequential. We remember Ereignisse. We anticipate future possibilities. The resulting perspective creates the sensation of temporal flow, but reality itself may not be flowing. Reality may already contain every moment. This possibility produces an unsettling consequence. If all moments already exist, then the future may be just as real as the past. Think carefully about what this means. At this very instant, your childhood exists within space-time. The stars visible thousands of years ago exist within space-time. Ancient civilizations exist within space-time. According to the block universe, future events also exist within the same structure, not because they have happened yet, but because the distinction between already happened and not yet happened may not be fundamental. The entire timeline exists as part of a larger whole. This idea challenges some of the deepest assumptions humans possess. We normally think of existence as a process of becoming. Things happen, choices are made, events emerge from possibility, reality unfolds. The block universe replaces becoming with being. The universe does not continuously create itself. It simply exists. Every event occupies its place within space-time. The entire history of the cosmos forms a single geometric structure. Many people find this concept disturbing. One reason is obvious. What happens to free will? If future events already exist, are our choices predetermined? Are decisions merely features of space-time rather than genuine acts of creation? Physicists and philosophers continue debating these questions. Some argue that free will remains compatible with the block universe. others disagree. No consensus exists. Yet the challenge reveals how deeply this theory affects our understanding of ourselves. The issue becomes even more profound when we consider death. Ordinarily, we think of death as the disappearance of a person from existence. Someone lives, time passes. Eventually they are gone. But within the block universe, every moment of that person's life remains part of space-time. Their childhood still exists. Their experiences still exist. Their entire timeline remains embedded within the structure of reality. From this perspective, nothing truly vanishes. Events do not cease to exist simply because they lie in the past. They remain part of the cosmic architecture. This interpretation inspired a famous remark associated with Einstein after the death of a close friend. He suggested that the distinction between past, present, and future may be a stubbornly persistent illusion. The statement remains one of the most quoted observations about time ever made, because it captures the strange implication at the heart of relativity. The boundaries separating temporal categories may not be as real as they seem. The mystery deepens when we ask what consciousness is doing within such a universe. If all moments exist simultaneously, why do we experience only one moment at a time? Why do we move through life sequentially? Why do memories point backward rather than forward? Why does awareness appear attached to a particular location within space-time? The block universe does not fully answer these questions. In many ways, it shifts the mystery rather than solving it. Asking why time flows, we begin asking why consciousness experiences flow. Asking how the future becomes the present, we ask why awareness encounters events in sequence. The focus moves from physics toward the nature of experience itself. Some philosophers compare the situation to a film reel. Every frame already exists on the reel. The entire movie is present from beginning to end, yet the audience experiences the story frame by frame. The sensation of motion emerges from how the frames are encountered, not from the existence of a moving object inside the reel. Similarly, consciousness may experience reality sequentially, even if space-time itself exists as a complete structure. Whether this analogy is correct remains uncertain, but it illustrates how radically different the block universe is from ordinary intuition. What makes the theory so powerful is that it emerges naturally from some interpretations of relativity. It is not merely speculation. It reflects genuine features of how space-time behaves within modern physics. Many researchers remain uncomfortable with its implications. Alternative interpretations exist. Some theories attempt to preserve an objective present. Others propose that reality genuinely evolves. The debate remains active. No final answer has been reached. Yet, regardless of whether the block universe proves correct, it reveals something remarkable. The deeper science investigates time, the less obvious temporal flow becomes. The moving present begins to fade. The past and future become less distinct. Reality transforms from a river into a structure, from a process into a geometry, from a story unfolding into a completed pattern. And if that possibility is already difficult to accept, the next question is even more unsettling, because the block universe still assumes that time exists as part of space-time. But what if time itself is not fundamental? What if the universe can exist without time altogether? What if time is merely an emergent feature arising from something deeper? And what would reality look like if time completely disappeared? To approach that mystery, we must consider one of the most extreme possibilities ever proposed by modern physics: a universe in which time does not exist at all. For most of your life, you have probably treated time as something unavoidable. It is always there. Every thought depends on it. Every movement depends on it. Every memory, every plan, every heartbeat unfolds within it. Time seems so fundamental, that imagining reality without it feels impossible. After all, how could anything exist if time disappeared? How could events occur? How could change happen? How could the universe function at all? Yet, one of the strangest possibilities in modern physics is that time may not be fundamental. It may not sit at the foundation of reality. Time may emerge from something deeper. And if that possibility is true, then asking what happens when time disappears becomes one of the most important questions we can ask. Because the answer may reveal what reality truly is beneath the world we experience. To understand this mystery, we first need to recognize how deeply time shapes human thinking. Almost every sentence you speak depends upon temporal concepts. You remember the past, you act in the present, you anticipate the future. Your entire sense of identity is organized around a timeline. You believe you were once a child. You believe you are older now. You imagine future versions of yourself that do not yet exist. Time provides the framework that holds these experiences together. Remove time, and the structure seems to collapse, at least from the perspective of everyday intuition. But physics often forces us beyond intuition. The deeper scientists investigate the foundations of reality, the more frequently time begins to behave like a secondary feature rather than a fundamental ingredient. Some equations describing the universe work surprisingly well even when time is not treated as a basic variable. This observation has led certain physicists to ask a remarkable question. What if time emerges from relationships between things rather than existing independently? Imagine a clock. The clock appears to measure time. Its hands move, its numbers progress, seconds pass. But the clock is not creating time. The clock merely tracks change. If absolutely nothing changed anywhere in the universe, would time still exist? The question sounds simple, yet it becomes surprisingly difficult to answer. Perhaps time is not an independent entity at all. Perhaps time is simply a way of describing change. If so, then what we call time may emerge whenever systems interact and evolve. The deeper reality might consist not of flowing moments, but of relationships between states. This possibility becomes easier to understand through a familiar example. Imagine a flipbook. Each page contains a slightly different image. When the pages are turned rapidly, motion appears, a character walks, an object moves, a story unfolds. The motion seems real, yet no individual page contains movement. Movement emerges from relationships between static images. Some researchers wonder whether time itself might arise similarly. The universe may consist of configurations connected through relationships. The flow of time could emerge from how these configurations are experienced. At the deepest level, there may be no flowing temporal river at all, only structure, only relationships, only patterns. This idea becomes especially important in attempts to unify quantum mechanics and gravity. For decades, physicists have struggled to create a theory of quantum gravity, a framework capable of describing the quantum world and space-time simultaneously. Yet many approaches encounter a surprising result. Time begins to disappear from the fundamental equations. One famous example comes from the Wheeler-DeWitt equation. In philosophical form, the equation describing the entire universe appears strangely timeless. The variable representing ordinary time does not appear in the way physicists expected. This result shocked many researchers. How could a theory describing reality omit something as obvious as time? The answer remains uncertain, yet the equation suggested that time may not belong at the deepest level of description. Time may emerge later, much like temperature emerges from the motion of countless particles. Consider temperature. A single molecule does not possess a temperature in the ordinary sense. Temperature emerges when vast numbers of particles interact. It is a large-scale property, a useful description, not a fundamental building block. Similarly, time may emerge from deeper processes occurring beneath the level we normally observe. If this is correct, then asking what happened before time began may be meaningless. The question assumes that time already exists. But if time itself emerges from more fundamental structures, there may be no before, no earlier moment, no prior stage. The concept would fail, in the same way that asking what lies north of the North Pole fails. The question sounds reasonable until you realize the framework itself no longer applies. This realization has profound implications for the origin of the universe. People often imagine the beginning of the cosmos as a moment in time, a first instant, a starting point. But if time emerged along with the universe, then there may have been no earlier temporal state. The universe would not begin within time. Time itself would begin as part of the universe. This possibility completely transforms how we think about existence. The mystery is no longer what happened before the beginning. The mystery becomes how time emerges at all. How does a timeless reality produce temporal experience? How does a world without time give rise to a world filled with clocks, memories, and change? No one currently knows. Yet some fascinating ideas have emerged. Certain approaches suggest that time arises from entanglement and information. Others propose that it emerges from thermodynamics and entropy. Still others argue that consciousness may contribute to the appearance of temporal flow. Each proposal attempts to explain how the familiar experience of time could emerge from deeper timeless structures. The challenge is enormous because human intuition depends completely upon temporal thinking. Every explanation we create unfolds through sequences. Causes precede effects, questions precede answers. Events follow one another. Trying to imagine a timeless reality is like trying to see beyond the limits of the mind's operating system. Our thoughts naturally convert everything into temporal narratives. Yet physics repeatedly suggests that reality may not be obligated to match those narratives. The implications become even more unsettling when we think about change itself. Ordinarily, change requires time. A seed becomes a tree, a child becomes an adult, a star forms and eventually dies. These transformations appear inseparable from temporal flow, but in a timeless framework, change may not be fundamental. Different states simply exist within a larger structure. The appearance of change emerges from relationships between those states. Imagine standing before a vast mural stretching across an entire wall. One section depicts spring, another depicts summer, another depicts autumn, another depicts winter. The mural itself does not change. All seasons exist simultaneously within the artwork. Yet an observer moving along the mural experiences a progression. A sequence emerges from perspective. Some timeless interpretations of reality resemble this idea. The universe may contain countless states within a larger structure. Temporal flow emerges from how those states are experienced, rather than from objective movement occurring within reality itself. This possibility challenges one of our deepest assumptions. Perhaps the universe does not evolve through time. Perhaps time emerges from the structure of the universe. The distinction is subtle, yet it changes everything. Because if time is emergent, then the question we have been asking throughout this journey may need to be reformulated. We have been asking what exists between moments. But perhaps moments themselves are not fundamental. Perhaps the deeper reality contains no moments at all. Perhaps what we experience as time emerges from something that does not resemble time in any recognizable sense. Something beyond the past, beyond the present, beyond the future. Something from which all temporal experience arises. And this realization brings us to the final mystery. A mystery waiting at the edge of physics, philosophy, and human understanding. Because after exploring Planck time, quantum uncertainty, relativity, space-time, the block universe, and the possibility of a timeless reality, one question still remains unanswered. What actually exists between moments? Not mathematically, not metaphorically, but in reality itself. And that final mystery may be the deepest one of all. We began with a question that sounded simple. What exists between moments of time? It seemed like a puzzle that physics should already have solved. After all, modern science can detect particles smaller than atoms. It can observe galaxies billions of light years away. It can calculate the behavior of black holes. It can trace the history of the universe back nearly to its beginning. Surely a civilization capable of such achievements should be able to explain what happens between one moment and the next. Yet as we have travelled deeper into the mystery, something unexpected has happened. The question has become harder, not easy. Every answer has revealed another layer of uncertainty. Every explanation has opened another door. And now, standing at the edge of what science currently knows, we encounter a startling possibility. Perhaps there is no between, or perhaps the between is the deepest hidden layer of reality itself. To understand why this mystery remains unsolved, consider everything we have discovered. We learned that continuous time may be an illusion created by perception. We learned that ancient philosophers doubted the reality of temporal flow long before modern science existed. We explored the possibility that time possesses a smallest meaningful scale. We encountered Planck time, where our current theories begin to fail. We examined the idea that reality might advance through discrete frames. We entered the quantum world, where certainty dissolves into probabilities. We discovered that physics struggles to define the present moment. We considered whether reality behaves like an informational process. We followed Einstein into the strange landscape of space-time. We encountered the block universe, where the past and future may coexist. We explored the possibility that time itself is not fundamental. Each step carried us farther from common sense. Each step revealed that time is far stranger than it appears. Yet none of these ideas fully answer the original question. What exists between moments? The reason is surprisingly simple. No one knows what a moment actually is. Think about that carefully. The entire mystery depends upon a concept we cannot clearly define. What is a moment? Is it an indivisible unit? A region of space-time? A feature of consciousness? A relationship between events? A process emerging from information? A property of observation? A useful illusion? Physics provides remarkable mathematical descriptions of how systems evolve. But when we ask what a moment fundamentally is, certainty begins to disappear. And this uncertainty changes the nature of the problem. Perhaps asking what exists between moments is similar to asking what exists between the frames of a film. If reality is fundamentally discrete, there may be nothing between them. One frame exists, then another. No hidden interval separates them. The notion of a between would be an artifact of human intuition, a question generated by minds accustomed to continuous experience. But another possibility exists. Reality may be fundamentally continuous. There may be infinitely many intermediate states connecting every moment. The apparent boundaries would be conveniences created by perception and measurement. The universe would flow without interruption. The between would contain endless structure, endless detail, endless transitions. Both possibilities remain open. Neither has been confirmed. And this is where the mystery becomes truly profound, because the question may point toward something deeper than time itself. Imagine standing before a vast ocean at night. You can see waves moving across the surface. You can measure their height. You can observe their speed. But if you focus entirely on the waves, you may overlook the ocean beneath them. The waves are real, yet they emerge from something deeper. Similarly, moments may be real, but they may emerge from a deeper layer of reality hidden beneath time. The true mystery may not concern the spaces between moments. The true mystery may concern the foundation from which moments arise. Some physicists believe this foundation could involve quantum information. Others believe it could involve unknown geometrical structures. Some propose networks of relationships existing beneath space-time. Others suggest entirely new principles that have not yet been discovered. No one knows which path, if any, is correct. Yet a common theme appears again and again. Time may not be the deepest level of reality. It may be something that emerges, something constructed, something arising from processes we do not yet understand. This possibility carries extraordinary implications, because if time emerges from something deeper, then the between may exist outside the framework of time altogether. The hidden layer connecting moments may not consist of smaller moments. It may belong to a completely different category of reality, a category for which ordinary language is inadequate, a category that cannot be visualized because every image we create already assumes time. Human thought itself becomes a limitation. Every sentence unfolds sequentially. Every explanation progresses from beginning to end. Every idea occupies a position within a timeline. Trying to imagine a reality beyond time is like asking a two-dimensional being to imagine depth. The mind reaches the edge of its familiar tools, and yet the mystery remains. Some researchers believe future breakthroughs in quantum gravity may eventually reveal what lies beneath space-time. Others suspect that entirely new forms of mathematics will be required. Some think consciousness may play a role in understanding temporal experience. Others argue that consciousness emerges from the same deeper structures we are seeking. The possibilities remain open, the answers remain hidden. What makes this mystery so powerful is that it touches every aspect of existence. You are not separate from the question. Your thoughts unfold through time. Your memories depend upon time. Your sense of identity depends upon time. The mystery of moments is also the mystery of yourself. Every experience you have ever known exists within this unfolding sequence we call temporal existence. And yet we still do not know what carries reality from one instant to the next. Pause for a moment and consider how extraordinary that is. Human beings have mapped the surface of distant planets. We have split atoms. We have measured gravitational waves traveling across the cosmos. We have photographed black holes. Yet we still cannot fully explain the mechanism connecting one moment of existence to the next. The most familiar feature of reality remains one of the least understood. Perhaps future generations will solve the mystery. Perhaps new theories will reveal hidden layers beneath space-time. Perhaps the question itself will be reformulated in ways we cannot yet imagine. Or perhaps the universe will continue guarding this secret. A reminder that even in an age of astonishing scientific achievement, profound mysteries still surround us. And maybe that is the most important realization of all. The universe is not merely stranger than we once believed. It may be stranger than our minds are currently capable of believing. Somewhere beneath clocks, beneath gravity, beneath quantum fields, beneath space-time itself, there may exist a deeper reality from which moments emerge. A reality hidden behind every second of your life. A reality present in every heartbeat, every thought, every memory, every star, every galaxy. A reality so close that you have never been separated from it, yet so mysterious that science still cannot describe it. And perhaps right now, as one moment becomes another, you are experiencing that mystery directly, not around you, not far away in the cosmos, but here, in the silent transition between this instant and the next. After everything we have explored, one question remains. Moments come and go. The universe changes. Stars are born and die. Entire galaxies drift through space. Yet physics still cannot fully explain what carries reality from one instant to the next. Perhaps time flows. Perhaps it emerges. Or perhaps every moment exists all at once, and the passage of time is only a story our minds create. Whatever the answer may be, the space between moments remains one of the deepest mysteries in the universe. And for now, it is a mystery we are still learning how to ask.